Hello and welcome to the second challenge of C3. This video will introduce you to some of the concepts covered in this weekend's challenge. We will also let you know what materials you should have on hand and what software you should download. This task explores the physics of sound, a subject called acoustics. Through this task, you will learn about the acoustics behind common musical instruments. You will also learn to use digital audio workstation software to record and edit audio, and then use video editing software for your final submission. For this task, you will need a phone or a laptop with video and audio recording capabilities. Watch the BandLab tutorial for instructions on how to use this required software. If this software does not work for you due to connectivity issues or other problems, there is a tutorial for a different software called Audacity. You will need to find your own video editing software that you can use to edit footage and add background music from a pre-recorded file. Let us know if you're having trouble finding video editing software. For your materials, you will need to use household objects as building materials. You may use any materials you want, but we suggest that it might be useful to have materials like PVC pipe, garden hose, rubber bands, plastic straws, wine glasses, or empty containers on hand when you're doing the challenge. But the materials that you use for this challenge are up to you.
I think it's really important for you guys to understand some background information about this task. So I'm going to go into a little bit about acoustics. So every sound that we hear is actually our ears picking up disturbances in the air called sound waves. These waves are caused by vibrating objects or air columns, and they travel through the air to reach our ears, where we perceive them as sounds. So a sound wave looks something like this, right here. This vibration could be chalk sliding across a chalkboard, a glass being tapped with a fork, a guitar string being plucked, or the movement of a speaker. Musical instruments create sound by causing these vibrations in different ways, and the type and the speed of these vibrations influence how we perceive the sound through qualities like pitch, volume, and timbre. Sound waves will always travel through the air at approximately the same speed, which is the speed of sound. However, the size of these waveforms can vary depending on the type of movement that caused them. So, pitch is a measurement of how high or how low a note sounds. This is caused by the frequency of a tone or the number of vibrations that happen every second. Frequency is measured in hertz, or a number of cycles per second. Think of the word frequent. A higher frequency means something is happening more frequently. Notes with higher frequencies will sound higher than notes with low frequencies. Musicians use the frequency of a note to measure its pitch and make sure that the notes are in tune with each other. Many tuning tools used by musicians can measure the frequency of a tone. So like I highlighted, the frequency of a tone is one that happens more frequently. So if we look at these three waves here, you can determine which one is happening more frequently or which one has a higher pitch. So as you can see, the cycles in this wave are not as many as compared to this wave down here. So the volume is a measurement of how loud or soft a note sounds. This is caused by the changes in the vertical size of a sound, or its amplitude. So the amplitude is from this point here to this point here. As you can see, this point to this point is much higher than compared to, for example, this point to this point. A sound wave with a larger amplitude, like this one here, will be louder than a smaller one. So we can infer that this sound wave here is much louder than compared to this one. Timbre is a qualitative description of an instrument's tone caused by the mechanics of sound production. To understand timbre, imagine hearing the same note played at the same volume by a trumpet and by a violin. Even though the pitch and the volume are the same, the two notes sound very different. This is because of their timbre. Also really important that you guys understand the musical concepts. Each instrument plays a different role in a piece of music. Instruments can provide a beat, a melody, or an accompaniment. Not all of these elements are necessary all the time, and sometimes a single instrument can do 2 or 3 of them at once. So, starting out, a beat keeps the time in a piece of music. Often it is played by the percussion, but any instrument can keep the beat. The melody is the main tune of a piece of music. It can be played by one instrument at a time or multiple instruments, and instruments can also take turns playing the melody. The accompaniment provides a background for the melody. It can follow the same rhythm as the melody, a contrasting rhythm, or something completely different. The accompaniment often plays in harmony with the melody, which means that it plays notes that support the melody.
For this challenge, you will also need to understand the different types of musical instruments. We're going to talk about 3 different instrument families which sound different because they each produce their vibrations in a different way, which changes their timbre. The first family of instruments is called the wind instruments. These create sound by causing a column of air to vibrate when the player breathes through it. This family includes instruments like trumpet, flute, clarinet, and bassoon.
Reed instruments include a thin membrane called a reed that vibrates when a player blows through it, which then causes the air in the instrument to vibrate. Brass instruments work similarly to this, except that the initial vibration is caused by the player's lips vibrating instead of a reed. The vibration in a flute is caused by blowing across a hole, creating a vibration of air at that hole that resonates through the instrument. In general, if you are blowing air through your instrument to create a sound, it's probably a wind instrument. Wind instruments create higher sounds when the airstream going into them is faster, and lower sounds when it is slower. They also create higher sounds when the membrane has more tension, and lower sounds when there is less tension.
Percussion instruments create sound by vibrating when they are hit. This family includes instruments like drums, cymbals, and xylophone. Percussion can be pitched, like xylophone or marimba. Pitched percussion instruments usually have many different sized and shaped pieces that produce different pitches. Smaller pieces typically produce higher sounds, and larger pieces produce lower sounds. Pitched drums, like timpani, can sound lower or higher because of their size or the tension of the drum head. Smaller drums produce higher sounds, and more tension also produces higher sounds. Percussion can also be unpitched, like many drums. Notice that it does not sound like notes are being played. String instruments create sound by causing a string to vibrate. This family includes instruments like violin, guitar, and piano. The string could be plucked like a guitar, the string could have a bow drawn across it like a violin, or the string could be hammered or hit like a piano. If your instrument uses a vibrating string, wire, or rubber band, it's probably a string instrument. In general, string instruments produce higher pitches when the string is shorter, thinner, and pulled tighter. One interesting thing to note about the piano is that although it is a string instrument, the strings are hit to produce sound, so technically it is also a percussion instrument. This slide summarizes the instrument families that you will need to know for this task. You can pause the video at this point to use as a reference to review these instrument families. You will be using all of this knowledge in this week's tasks, where you will relate music, physics, technology, design, and proportions to create your final submission. We look forward to viewing all of your submissions, and good luck with the second challenge of C3.